Hello and welcome to the course Climate Hazards and Disaster Mitigation. Today we begin a new module. So today's lecture is on science meets policy and disaster mitigation. So in this lecture our learning objectives are: we'll understand the connection between science and policy in disaster management, we'll identify how disaster mitigation benefits from evidence-based decisions, we'll also learn about the institutional setup for disaster mitigation in India, and we'll explore various disaster mitigation programs formulated in Indian context. Disaster mitigation refers to the measures taken before a disaster to reduce or prevent its impact on people, property and the environment. According to Disaster Management Act 2005, India, mitigation means measures aimed at reducing the risk, impact or effects of a disaster or threatening disaster situation. Disaster mitigation is aimed to minimize the loss of life and damage by reducing the exposure and vulnerability to hazards. Mitigation is usually a long-term proactive strategy which is adopted for disaster risk reduction. So you can see under mitigation there are different aspects being covered, like community resilience, public information and warning, long-term vulnerability reduction, operational coordination, planning, threats and hazard identification, risk and disaster resilience assessment. What are the types of mitigation? There are two major types. One is a structural and second is non-structural. So all physical measures that include, such as flood embankments, cyclone shelters or earthquake resistant buildings, they come under structural measures. Non-structural are basically the policy measures that can relate to land use planning, create awareness in people, insurance programs and revising the building codes. Some examples are like if construction of dams and levees to flood control. So this is a structural measure. Enforcing seismic building codes in earthquake prone regions, this is a non-structural measure. Mangrove plantation along coastline to reduce storm impact, again this is a structural measure. Along with that there can be some coastal defense structures can also be created. Now what is the science behind disaster mitigation? Why it is important? Because science provides essential tools and techniques to reduce the impact of natural hazards. Key ways in which science supports disaster management are: number one, hazard mapping. If we are able to identify which regions are more prone to disasters, it can be earthquakes, floods, drought, etc., using geological and weather data, we could help in planning our land use very safely and designing our infrastructure accordingly. So in the areas which are more prone to flood, the infrastructure can be designed in that particular way. In the areas more prone to earthquake, which are in earthquake zone 6 or zone 5, the buildings can be designed according to that. So that is why hazard mapping is very important. Next is early warning system. So by collating all the knowledge and creating a real-time system, we can utilize real-time data to predict hazards and their tracks like cyclones or heavy rainfall, and that can help us mitigate much of the risk. We can give timely alerts to save lives and reduce the damage accordingly. Remote sensing and GIS. Remote sensing and GIS helps to monitor the Earth's surface and even the atmospheric conditions using satellites. We can track the events like floods, wildfires and storms using these techniques. Modeling and risk assessment. We can use computer models to forecast future hazards and evaluate the potential impacts. These can also be used to support planning and even prioritize mitigation measures. For example, IMD utilizes satellite and ocean data to issue cyclone warnings and thereby help to protect the lives and property. Okay, so there is a kind of warning or forecast being given that these areas can be affected by cyclones, then people can be evacuated. Central Water Commission, it provides continuous monitoring of river gauges and disseminate water level information to provide flood warnings. So that is where the science is important. Again, this science is important in the aviation sector also, because many times your conditions are not conducive, so you have to pass the signal to the airplane that the plane cannot land at this place, so the flight has to be diverted to other safer place. Role of science and technology. Science and technology are crucial across all phases of disaster management, may it be prevention, mitigation, preparedness, response and recovery. With the help of S&T tools, we are able to develop complex and nuanced risk and vulnerability assessment, moving just beyond the hazard data by including more social and economic factors. Our early warning systems, they help in tracking the cyclones, providing earthquake warnings, tsunami warnings, and even flood forecasting models to provide very critical and timely information that could help save lives. Integrating GIS solutions and data analytics could help us collect information on a very large scale and model its potential impacts and achieve targeted local solutions. Disruptive technologies, artificial intelligence, robotics, and green technology can offer newer methods for effective risk management and resilient infrastructure development. And now this science has to be bridged with policy, because many a times what happens, the scientists and researchers create novel approaches and techniques, but they are not translated to field. So the policy linkage is a major task. So the science has to be linked to the policy, and it can provide a smooth facilitation of the science for its implementation. So science policy interface is referred to as a process of linking scientific knowledge with policy making. So there is a quote: without science, policy is blind, and without policy, science is powerless. So there is, of course, if you just do on science which is not implementable, there is no use, and if there is no policy, then what is the use of doing any science? So science policy interface is a mechanism for linking scientific research with policy decision through ongoing communication and collaboration. Its purpose is to ensure that the government policies are informed, effective, and evidence-based, using scientific data, findings, and expertise to guide the creation and evaluation of these policies. Science policy interface facilitates evidence-based decision making by bridging the gap between scientific research and the political processes, because many a times the bureaucrats and the politicians offer they are the decision makers or the lawmakers, so they should be convinced with the science findings so that they can find a way to implement those into decision making. Why collaboration is important? Because it builds a bridge between the scientific knowledge and the practical policy making. It ensures that the evidence-based, timely, and relevant decisions are made which are catering to the real-world challenges. For scientists, why it is important? Because it's helped make their research more practical and policy-oriented. For example, if government declares that we want to create a new building bylaws, so the science will be oriented towards that to find out various factors that affect how the things have changed over the past years and try to come up with newer provisions. So that is why the science has the policy is the backing of the science. It also ensures scientific findings are communicated very clearly and in formats that are useful to decision makers. It promotes real world application of scientific studies in disaster management. Why it is important for policymakers? Because they have access to accurate and up-to-date scientific evidence for planning and action, so that anything which they take, which the action is implemented in the field, has a scientific basis. So tomorrow if someone questions that thing in the court of law, then it can be defended with the help of scientific facts. It enables better risk assessment and sustainable disaster risk reduction, and supports informed decision for long-term community resilience. The interaction between two domains is very essential, but there are a lot of challenges which is often referred to as a science policy gap. So many researchers are targeting these gaps. Why these gaps are there and how we can be bridged? One is the knowledge transfer. A major challenge is translating the nuanced scientific information into clear, decisive policy recommendations. So whatever is a scientific terms, it has to be converted into very plain language summary for the ordinary people to understand. If we put lot of scientific terms and jargons, they will not be able to understand that what is a simple meaning conveyed by that particular document. Next is communication. A language barrier often exists, as scientific jargon can hinder effective communication with policy makers and the public. That is what I discussed. Institutional gaps. The lack of formal dedicated institutions or mediators of science that bridge academia and government can slow the integration of new research into practice. So like there are many institutions which are particularly dealing with the public policy. So why this public policy? So that they can translate science into plain language and then that can be disseminated further. So such public policy institutes are more and more coming up, which are filling this particular gap. The link between science and policy for disaster mitigation is very crucial for effectively reducing the risk and impacts of natural hazards. The relationship can be summarized by a continuous cycle of information, decision making and action. So it is a continuous cycle. If the action is not proper, that information is sent back, then the decision is modified and next action is oriented. So science provides evidence. Your scientific research in the field like seismology, meteorology, hydrology and engineering provides a foundational fundamental knowledge to understand the hazards. The scientists collect valuable data, develop models, forecast events and assess vulnerabilities. So this evidence is very essential in identifying the potential risks and predicting the likely impacts of future disasters. Now when the policy turns evidence into action, because policymakers are at different levels, may it be local, regional, national and international levels, they use this scientific evidence to formulate and implement strategies. You might have heard of COP26 these kind of summits. So these are mainly climate change summits. So if you want to make decision, you should have certain scientific knowledge. Based on this, the international lawmakers, there is a group of countries which will discuss, deliberate and prepare a roadmap to mitigate the climate challenge. Effective policy translates scientific finding into concrete actions, regulations and plans. A few examples are: you can develop early warning systems informed by meteorological forecast, establish land use regulations based on floodplain and seismic zone maps, mandate building codes to incorporate scientific understanding of hazards, and allocating resources for preparedness. In this area this is more prone to this hazard, then resources can be allocated according to that. Informed decision making. Science provides why we should integrate these things, because science provides rigorous evidence, data and predictive modeling needed for policymakers to make objective and informed choices and reduce the reliance on assumptions, ideology or political expediency. So it should not be based on somebody's assumptions. Okay, I believe that coastal areas will be affected by tsunamis, so create tsunami barriers everywhere. So it should not go that way. It should assess the vulnerability of the region and should have very strong data backup. Improved effectiveness and outcomes. So if the policies are grounded on sound scientific research, they are more likely to achieve success, and the public involvement will also be appreciated, and it will also lead to more economic development and environmental protection. Problem solving for complex issues. Many pressing issues like climate change and pandemics like COVID-19 and pollution are inherently complex and require scientific understanding to develop effective strategies. For example, somebody says, okay, air pollution is more predominant in a particular city, for example Delhi, you do XYZ measures. Unless and otherwise you study all the factors and its drivers and other things, you cannot propose a robust solution. So for that, science is very important. Enhancing public welfare and safety. So science informed decisions and policies can protect vulnerable population, improve public health outcomes, safeguard lives and infrastructure from hazard. Also it could ensure resource efficiency by targeting the root cause of the problem through research and integration, helps making costly mistakes, inefficient interventions and waste of resources. Policies which are perceived as being developed through an open, transparent and evidence-based process tend to have greater public trust, legitimacy, fostering societal adherence and cooperations. So the decisions are very arbitrary, they do not have any scientific backing, public may protest, and ultimately the trust in the government and the functionaries would also reduce. Lastly, the science helps policymakers look ahead, explore emerging issues, build scenarios, design dynamic policies that can adapt to new information and evolving conditions. So you might have seen in the earlier lectures that building on the data, let us say this is the data till the 2025, and from that there are several scenarios being forecasted in the IPCC reports. So why these scenarios are there? So that scenario based analysis can be carried out. So that is very important when you want to do long term planning and adaptation measures. What is the role of policy? Policy provides governance, mandates and resources necessary to implement scientific findings very effectively. So what are the frameworks and mandates? So there are international and national policies like Sendai framework, then there is national disaster management plans which set the agenda and priorities for the action. What are the institutional structures? Your policies establish bodies like National Disaster Management Authority in India, European Union's Disaster Risk Management Knowledge Center to facilitate science policy collaboration. Also legal basis, so laws like Disaster Management Act 2005 India provide the legal authority for policies and establish role for different government levels. So policies help us cater to these aspects. In addition, resource allocation, so it will guide allocation of fund for mitigation activities and outline the financial support required for recovery and insurance mechanisms. Moreover, policies provide standardization and cooperation, that is they drive the development of common standards for data sharing, risk assessment methods and international collaboration also, which is known as disaster diplomacy across borders and even nations with complex diplomatic relationship. So if any kind of disaster happens in the immediate neighborhood of India, India has always responded positively, maybe the Nepal earthquake or some recent tsunami in Sri Lanka or some water crisis in Maldives. India has extended its disaster diplomacy. So disaster diplomacy is a very very upcoming term in the recent era. Inclusivity, policies should ensure that all vulnerable groups including women, children, differently abled people are considered in relief, rehabilitation and planning. And lastly, policy aim to bring clarity in disaster management efforts through defined roles and responsibility so that there is transparency and accountability. Discussing policy frameworks, so global frameworks, there is a Sendai framework for disaster risk reduction. It is proposed by the United Nations. So the priorities include understanding risks, strengthening governments and investigating resilience. There is another Hyogo framework. So it is a former global framework which was institutionalized for disaster resilience. Coming to Indian context, we have the National Disaster Management Act 2005 of India. It provides legal and institutional framework for disaster management at state, national and district levels. It covers prevention, management, preparedness, response and recovery for disasters. Next is National Policy on Disaster Management 2009. It aims for a safe and disaster resilient India, and it largely focuses on a holistic technology driven approach covering all stages of disaster management. Looking at the institutional setup, so we have NDMA, that is National Disaster Management Authority. It is an apex body led by the Prime Minister and sets national policy and ensures implementation. Then there is state. Each state has its disaster management authority. It is led by respective chief minister and it will implement state specific policies. Lastly, it is a district disaster management authority. It is headed by the district magistrate or collector and it looks at the district level. Institutional setup, further NDMA, like NDMA, so it is an organization, but there is a force on the ground that is called NDRF, National Disaster Response Force. It is a specialized Indian force under the Ministry of Home Affairs. It is responsible for swift professional response to natural and man-made disasters like floods, earthquakes, cyclones, deploying highly trained teams with specific skills which can include engineers, medical staff, dog squads for search, rescue and relief operations. So if anywhere there is calamity, so these NDRF people will be deployed for rescue operations. It was established in 2006 under the Disaster Management Act 2005. The motto of NDRF is Aapda Seva Sadaiv Sarvatra, that is saving lives and beyond. Analogous to NDRF, there is a State Disaster Response Force, which is called SDRF. It is a specialized force including police and fire for calamities for state specific disasters. Now looking at the institutional setup, so there is a Ministry of Home Affairs. Under that you have NDRF, then it is chaired by a DG rank officer. Then there is NDMA, then SDMA for state. So NDMA is more for coordination, which will coordinate with all the agencies, and NDRF will be for emergency response, and there is a National Executive Council which will prepare the National Disaster Management Plan. Now there are various ministries which have designated as nodal authorities for specific disasters in India. So this shows the emergence of multi-level links between ministries and the disaster mitigation framework. For example, earthquake, the ministry's disaster management is done by Ministry of Home Affairs, and the nodal Ministry of Earth Science, because Earth Science is responsible for collecting data and all other information. Flood, Ministry of Water Resources. Drought, hailstorm, etc., Department of Agriculture. Landslide, Ministry of Mines. Avalanche, Ministry of Defense, because it is mostly in the border areas. Forest fire, Ministry of Environment and Forest. Nuclear disaster, Ministry of Atomic Energy. Chemical disaster, Ministry of Environment and Forest. Biological disaster like COVID, Ministry of Health and Family Affairs. Rail accidents, Ministry of Railways. Cyclones, Ministry of Earth Science. Tsunami, Ministry of Earth Science. Aviation and road accidents, respectively by Ministry of Civil Aviation and Ministry of Road. So these are the nodal ministries which will look after all these kind of disasters. Now there should be an interface among the stakeholders. Who are stakeholders? Those who are involved in the decision process. You and I are we collectively form the stakeholders because we at some level are part of this entire setup. So the interface between the stakeholders and disaster management framework is permanent, which is backed by legislative measures and decisions such as those taken for establishment of the bodies, committees for managing disasters, and government orders to execute them. These decisions or measures guide the composition of structure by identifying the stakeholders involved. For example, if you consider floods, so who are the stakeholders? They are the irrigation department, then there is a local government body, then there are farmers, those who are affected by that, there are agriculture committees. So these are form the stakeholders. Similarly for droughts, so for each disaster the stakeholder committee will be different. The expertise based interface emerge when the stakeholders serve as service providers to the disaster management framework. For instance, the institution under Ministry of Earth Science and Ministry of Water Resources, now it is named as Ministry of Jal Shakti, that is IMD and CWC respectively provide information on weather and climatic parameters and potential hazards and threat to the nodal authority. So if the nodal authority is a district collector, then IMD and CWC will provide alerts to the district collector. These organizations are involved in disaster planning activities, like CWC will help in flood zonation and floodplain management, while IMD will prepare in creating a rainfall or cyclone hazard map and database generation. So you can see that it starts with a political interface, then there is development and environmental and climate change, then there is your disaster risk reduction, then there is one chain going on for mitigation and adaptation where you have structural and non-structural measure. Second is more on a sustainable case where the financial resources, after disaster funding, pre-disaster mitigation, and that all comes, and ultimately a sustainable development framework. So these are all the stakeholders. So on the left you have the policy support, on the right you have the resource support. So they should combine and to get a sustainable development in place. So some flood mitigation programs, so it is implemented by Ministry of Water Resource, now it is Ministry of Jal Shakti. It is guided by Flood Management Program 2007. Under this, it provides financial assistance to states for flood control. It focuses on more critical flood prone areas. So if some areas are more prone to flood, it will provide some funds. So in every budget you will see that there is a fund allocation to create embankments or other structures for flood protection. So in that there is a flood management and border areas program called FMBAP. So this is an umbrella scheme for central funding. So there are two components. First is the flood management component. So it supports the structural works like embankments, drainage development and anti-erosion. And second is the RMBA component, which provides 100% central assistance for flood protection and forecasting in international border rivers with neighboring countries like China, Pakistan and Bhutan. So where we have the cross-boundary rivers, so for those this component is there. There is another Mission Mausam, which is a multifaceted initiative aiming to make India weather ready by improving the climate and flood forecasting technologies. There is a flood risk mitigation scheme where multi-purpose flood shelters and river basing early warning systems are provided. So for flood control, dams are very common. Cyclone mitigation programs. So there is a National Cyclone Risk Mitigation Program, NCRMP. It is implemented in the 8 coastal states under 2 phases. Under phase 1, Andhra and Odisha were covered. In the phase 2, remaining states like Goa, Gujarat, Karnataka, Kerala, Maharashtra and West Bengal are covered. There are 4 components. The first is the early warning dissemination system. Second is the cyclone risk mitigation infrastructure. Third is technical assistance for capacity building. And fourth is the project management and monitoring. So these are the components of this program. Next is a drought mitigation program. So it is a multi-pronged approach through schemes like PMKSY, Manrega and other programs. So we have Pradhan Mantri Krishi Sinchai Yojana, which aims to enhance the irrigation and water efficiency. Then there is Mahatma Gandhi National Rural Employment Guarantee Act, which provides rural employment for water conservation works like check dams, farm ponds, etc. Pradhan Mantri Fasal Bima Yojana, it offers crop insurance against drought losses. Then there is National Rural Drinking Water Program. It ensures safe water supply to the villages. Heat wave mitigation programs. In 2024, India notified heat waves nationally as a disasters, enabling it to access the disaster mitigation funds. So several states have their own state specific programs. These are very instrumental in mapping risk hotspots and coming up with affordable local solutions to mitigate heat stress. Despite national guidelines, National Disaster Management Act Authority, the introduction of Indian Cooling Action Plan 2019 and the National Action Plan on Heat Related Illness, heat action plans across state often lack scientific rigor, dedicated funding and context specific implementation. So what are the key takeaways from today's lecture? The scientific evidence helps us understand climate disaster risk, and strong policies are essential to turn that knowledge into real world action. Effective risk reduction depends on coordination across institutions and scales, which are supported by reliable data and informed decision making. Disaster risk reduction cannot be treated in isolation. It must be embedded with sustainable development and ultimately highlighting the importance of science-informed governance for building a safer and resilient future. Here's an activity suggestion for you. You can find out institutional frameworks for disaster mitigation in other developed countries and list them. These are some additional learning resource. This is a report for the SAARC region, and this is a policy on disaster management. Thank you for attention. In the next lecture, we'll discuss disaster risk reduction.